So our next question is, how do we judge the probability of any particular ordering through which we judge all other probabilities? And Lewis argues that we do it in a way that's completely common sense and we would recognize, but we just never really paid attention to. And that's the idea of the general fit of a certain claim with everything else that we know or believe. Let me give you an example. Let's say I came up to you one day and I said, did you know that Mother Teresa hates Indian people? She's hated them all her life. It's been shown, we've got evidence to show that Mother Teresa really hated and actually tortured her patients. Now, many of you would go, that's silly. Everything I know about Mother Teresa, her character, the way she's behaved among Indians, the way she set up all these hospitals, what she sacrificed, all of these things wouldn't make sense. It doesn't fit what I know about her, right? Or if you don't take that very well, take Hitler. Let's say I tell you, we found evidence that Hitler has saved thousands of Jews during the Holocaust, that he hid them in these underground bunkers and sent them through this sort of underground railroad to Switzerland to avoid being killed by the Nazi death camps. Again, while possible, you would think it's intrinsically improbable precisely because of what you know already about Hitler and his character and his statements. And so therefore, we often judge the probability of something simply by its fit with everything else we know. And how do we do that? Well, something fits well when it explains the most with the least. This is a way that scientists judge between theories which have equal amounts of observational and logical evidence. Let me give you an example. Newton obviously has his theory of gravity that you're all very familiar with, the inverse square law. Einstein comes up with a new theory, the theory of general relativity. Their theories are very different from each other. Einstein's theory says that gravity is not a force, but actually a curvature of space-time. Notice how I say space-time and not space and time. Newton believes that there is this background container called space and time in which all events take place, two different things, space and time, independent of each other, and that events occur in this space and time, and that there is a force called gravity, a force of attraction. Obviously, these two theories have very different ideas about the general order of the universe. So now you might think, okay, what happened in the history of science is that Einstein's theory was proven by observation and Newton's wasn't. And of course, those of you who know a little science history would know that there was this famous Sir Arthur Eddington and his team observed the sun during a solar eclipse, where then you could observe the background stars, what is called sidereal light from behind the sun. You couldn't observe it when the sun's light is too strong, but during a complete solar eclipse, you can then observe that light. And Einstein's theory predicted that the light would be distorted as it goes close to the sun, passes the sun, because of the actual curvature of space. And Newton's theory predicts that it wouldn't do that precisely because light has too little mass. And so, thus you have these two theories with two different observational predictions, and Einstein's theory pans out, light is distorted, and Newton's theory doesn't. That's the traditional picture. But you don't understand something, that every theory can be changed a little to conform to the observational results. For example, if you take Newton's theory and instead of using traditional Euclidean plane geometry, you switch to what is called spherical geometry or solid state geometry, 3D geometry, it's provably equivalent to Einstein's non-Euclidean geometry. And thus you could actually, from Newton's theory, predict the exact same result that Einstein's theory predicts. In other words, you can fiddle Newton's theory so that it comes up with the exact same observational results, so that neither observation nor logic, because they're both equally consistent theories, would be able to tell you which theory is the more correct theory. This happens all the time in science. These are called observationally equivalent theories. Why then did we choose Einstein's theory over Newton? Any scientist will tell you because you get more bang for your buck with Einstein's theory. Einstein's theory posits fewer entities, okay? You have just space-time, which explains all of the gravitational effects, curvature of space-time, and you have a simpler geometry, set of geometrical principles. Newton's theory, you have space, time, and gravity, and you have to explain what's called attraction from a distance, which is very difficult to explain. And so therefore what you have is Newton's theory is bulkier, more principles, more things that have to be explained or have to be left unexplained, and therefore it doesn't integrate all of the data the way we want it as well as Einstein's theory. So in other words, why did we accept Einstein's theory? Because it illuminates all of the facts, but it does it in a way that integrates them all into a more unified whole. That is the way science really works at the level of whole theories, how we choose this particular theory of the universe's order versus this particular theory of the universe's order. We can't do it through observation because we don't have enough observational results, first of all. And second of all, even if we did, those observational results and their probability would still depend on, again, the background theory. And so our main way is what is called general fit, or as scientists like to call it, inference to the best explanation. Emphasis on the word best. It's an aesthetic judgment. It's not a judgment of logic. It's a judgment of which theory is the more beautiful, the more economical, the better theory. So now, again, let me give you another example in ordinary life how we do this. Let's say, for example, I find 2 copies of a diary of a person that I'm trying to figure out how they died. And I'm wondering, is this the person who killed them? And the diaries have a single entry that's almost exactly the same except the difference in 2 words. As I'm reading the entry, the one diary says, Reginald is kind. He calls me at all times of the night and asks me these deeply personal questions. It's really making me uncomfortable. That's the one version. The other is, Reginald is kind of creepy. He keeps calling me at all times of the night, asking me these really deeply personal questions. It's really making me uncomfortable. Which entry do you think is the more likely entry that was written down? Obviously the one that makes the most sense of what was said totally, right? Which fits with all else what is said. Does it fit very well to say Reggie is kind and then go on and say how he makes you really uncomfortable and how he calls you and asks you all these weird and deeply personal questions? It makes more sense to say that the original statement, when it was copied, dropped the words of creepy. Because once you put those in, it what? Illuminates the rest of the statements. You go, now I know why she's saying he's making him so comfortable. And now I know, and therefore integrates the whole passage into something that makes more sense. See that? Into an integrated whole. Otherwise, that statement, Reggie is kind, just dangles there, and we're wondering why she would say that when she goes on and says things that seem to say just the opposite. That's the idea of general fit. When we talk about miracles, we must remember this. Miracles are signs. They're like passages, they're like passages that, when inserted into the text of reality, should what? Illuminate it and tell us what it's all about. And so therefore, the way to judge the general probability or intrinsic probability of any miracle can't be how many times it has occurred. It can't be anything but something that has to do with the very nature of the universe itself and how likely such a thing as God interfering with nature would illuminate and therefore be a sign, which is what miracles are supposed to be. So in the rest of the book, he is going to use, Lewis, this criteria. When we judge any particular miracle, we have to ask the question, how well does it illuminate nature? How well does it explain nature and integrate all of these things into a single coherent whole? If it doesn't do that very well, then its intrinsic probability is very low. If it does it so well that we go, aha, that's what it's all about, then that in itself speaks in favor of its probability, in the same way that a good scientific theory that integrates the most facts and illuminates them all into a single coherent whole would be more likely to be true than a theory that doesn't do this. Inference to the best explanation is the best evidence that we can ever get about the probability of miracles. Then we can look at the specific historical information and evidence. If a miracle is intrinsically improbable, then the evidence that's going to be needed to prove it will be intrinsically high. But if we see it fits, then our likelihood of seeing the evidence in its favor becomes even more palpable.